it's me. Let's go to physics puzzle. We have a nice mix today of easy, medium, and hard. And first up is Earth and Sun. You see this picture? This represents the Earth and the Sun. The little square in the middle is Sun, and all the concentric circles around that are the Earth. But how do we know that? Well, if we measure the length of one of those circles, say from here to here, that's 24,860 miles. And coincidentally, that's also the circumference of the Earth. Therefore, the circles are the Earth. Question is, what is the area of the Earth? Now the area of a circle is pi times the radius squared. So you need to find the radius of this circle, which is the same as the radius of the Earth. If you can figure out the radius of this circle, you'll win a prize. Earth and Sun. Okay, so the radius of the Earth is about 3,950 miles. So let's take the square root of that times pi. In other words, we're going to compute pi times the squared. Where r is the radius of the Earth? That gives us about 1,270,042 square miles. So the area of the Earth is approximately 1,270,042 square miles. Okay, now let's look at this problem from another perspective. Let's start with the area of the entire circle. So we have a big circle with a smaller circle cut out of it. The large circle has a radius of 94 million miles. That's the distance from the center of the Earth to the Sun. So the area of that circle is pi times 94 million squared, or about 2.81 times 10 to the 14th power. Then we have the inner circle, which has an area of pi times 3,950 squared, or about 1.27 times 10 to the 8th power. So the difference between these two areas is 2.81 times 10 to the 14th power, minus 1.27 times 10 to the 8th power, which is 2.81 times 10 to the 14th power. Therefore, the area enclosed by the Earth is approximately 2.81 times 10 to the 14th power. But wait a minute. We already said that the area enclosed by the Earth is 1.27 times 10 to the 8th power. So why are we getting two different answers? Well, that's because the Earth isn't a sphere. It's slightly wider at the equator than it is tall. The equatorial radius is about 3,963 miles, and the polar radius is about 3,950 miles. So actually, the area of the Earth should be computed as follows. Pi times the equatorial radius squared times 4/3 plus pi times the polar radius squared times. However, our first computation was for the surface area of the Earth and not the volume. To convert the surface area to a volume, we have to add another dimension. So instead of going around the circle, we go around the circle and then we go up or down depending on how you want to look at it. So the area becomes the following. Pi times the equatorial radius squared times 2 times the height plus pi times the polar radius squared times 2 times the height. What's the height? Well, that's the thickness of the Earth, which is 3,950 or 7,900 miles. Plugging in the value for the height and the radius, we get approximately 1.27 times 10 to the 13th power. So how good were your answer? Well, if you got 1.27 times 10 to the 8th power for the area, that's pretty good, but not quite right, because that's the surface area. If you got 1.27 times 10 to the 13th power for the volume, that's fantastic. But again, that's only if we assume that the Earth is a perfect sphere, which it's not. If we take into account the fact that the Earth is a bit wider at the equator than it is at the poles, then we should use the formula that we developed earlier, which is 5.11 times 10 to the 8th power for the area, 1.27 times 10 to the 13th power for the volume. Now, you could probably see why I gave the hint that I did, because many people will make the mistake of using the surface area instead of the volume when they compute the answer. So keep that in mind. And how did you do overall? Well, here's your report card. Let's go to the next puzzle. Okay, on to the next puzzle. This one is called Spacewalk. Suppose you are on a space station that is in orbit around the Earth. You need to go outside and repair some damage. You put on your spacesuit and step outside. You take one step forward 5 meters, then you take another step forward 5 meters. But after taking these 2 steps, you notice that you are no longer standing directly beneath the part that you were originally looking at. It appears that you have moved sideways. In other words, you didn't move in a straight line. How could this happen? Please explain. Spacewalk. Okay, here's a possible explanation. You took your steps while you were rotating, so you weren't just moving forward, you were also moving sideways. There's a very interesting follow-up question to this. Suppose you wanted to walk 10 meters forward without moving side to side. How many steps would you have to take? And what would the angle between each of your steps have to be? That is a great question. And the answer is that you would have to take 10 steps, and the angle between each consecutive step would have to be 80 degrees. Okay, so let's suppose you take a step forward. Then you take another step forward at an angle of 18 degrees. If we draw a vector pointing in the direction of your first step and another vector pointing in the direction of your second step, then the vector, some of these 2 vectors will point in the direction of the third step. In other words, the vector, some of these 2 vectors will point 10 meters forward. If we repeat this process, then we'll find that the vector, some of the 3 vectors, points 10 meters forward. If we repeat this process one more time, then we'll find that the vector, some of the 4 vectors, points 10 meters forward. If we keep doing this over and over again, then we'll find that the vector, some of the 10 vectors, points 10 meters forward, so we can write the following equation. Step 1 plus step 2 plus step 3 plus step 4 plus step 5 plus step 6 plus step 7 plus step 8 plus step 9 plus step 10 equals 10. We know that the magnitude of each step is 5. So the question is, what is the angle between step 1 and step 2? Between step 2 and step 3, and so on, call the angle theta. Then we have the following equation. 5 plus 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 5, 10 asterisk 5 equals 10. Since the angle between each of the vectors is the same, we can write the following equation. 10 5 sine of theta equals 10. Therefore, sine of theta equals 1/5, or theta equals arcsine of 1/5, or theta equals 11.5 degrees. So it would take 10 steps of 5 meters each, with each step being 80 degrees apart, to walk 10 meters forward without moving side to side. Okay, that concludes today's episode. Please give it a thumbs up if you liked it, and subscribe if you haven't already. Thanks for watching. See you next time.